Today, we're going to talk about a letter. Just a simple letter, sent over 100 years ago from a poor clerk in India to a professor at Cambridge. But this letter? Well, it completely changed the world of mathematics because it was filled with ideas so wild, so profound, that at first they seemed like the ramblings of a total madman.
Okay, so let's just start with this. This is one of the ideas in that letter. Take a look. 1 plus 2 plus 3 plus 4, and you just keep going forever. You'd think the answer is infinity, right? I mean, of course it is. But the letter claimed the answer was negative 1/12. Now you're looking at that and thinking, no way. That's just wrong.
And that's exactly what the professor, G.H. Hardy, thought. His first reaction was, okay, another crank into the bin. But something made him look closer. And as he did, he realized that this wasn't just some mistake. It wasn't about simple addition. It was a completely different way of thinking about infinity, a way to assign a real, finite value to something that explodes forever. An idea that, believe it or not, is now crucial for things like string theory and quantum physics. So who on earth could come up with something like this?
Well, that man was Srinivasa Ramanujan. And you really can't understand his mathematics unless you understand the incredible, almost impossible journey he took to get them seen, from a small town in India all the way to the heart of the British academic world.
I mean, just look at this. This wasn't just about getting on a boat and traveling thousands of miles. This was like a collision of two different planets. You've got the ancient, spiritual, temple-filled world of South India on one hand, and the rigid, rational epicenter of Western science on the other. And Ramanujan was the person standing right in the middle of that collision.
So here's the thing about Ramanujan. He was the kind of genius that our formal education system just doesn't know what to do with. He literally lost his college scholarship because he was so completely obsessed with math that he failed all his other classes. So, to make a living, he ends up as a lowly clerk. But all day, while he's doing his accounting work, his mind is in another universe, scribbling in notebooks, discovering entire new fields of mathematics all by himself. That letter he sent to Hardy, it was basically a message in a bottle, thrown into the ocean, hoping that somewhere out there, one person in the world might understand him.
Now there's this myth that builds up around him, that he was this total unknown, a forgotten genius. And that's not exactly the whole story. The truth is, local Indian mathematicians knew he was brilliant. They didn't always understand what he was doing, but they knew it was special. They were the ones who helped him get a job, and they were the ones who pushed him, saying, "You need to send your work to the experts in England."
So can you imagine being Hardy? He and his colleague J.E. Little would spread these pages out and just stare at them for hours. And some of the theorems they recognize. They're like, okay, this guy isn't a fake. He's rediscovered some known mathematics. But then there was the other stuff. Things that were so strange, so alien, they just seemed to come from another dimension. Hardy famously said that these ideas had to be true because if they weren't true, no one would have the imagination to invent them. He knew, right then, he was looking at a mind on the same level as Isaac Newton.
So, what was in those notebooks? What was this incredible world that Ramanujan saw so clearly that nobody else did?
Well, his specialty was a field called number theory, and he was totally obsessed with something called partitions. Now, the basic idea is actually super simple, but the places he took it, they were just breathtaking.
Okay, so take a simple number, like 5. A partition is just any way you can add up positive numbers to get 5. So, 5 itself, or 4 plus 1, 3 plus 2, 2 plus 2 plus 1, and so on. Turns out there are 7 ways to do it. Easy enough, right? But what if I asked you to do that for the number 100? Any guesses? It has over 190 million partitions, and Ramanujan, with almost no formal training, created a formula that could figure that out, uncovering these deep, hidden patterns in the very fabric of numbers.
At this point, Hardy knew. He absolutely had to get this man to Cambridge. And what happened next? Well, it became one of the most famous and strangest collaborations in the history of science.
This slide really just nails their dynamic. It was like Ramanujan was a lightning storm, just this unbelievable, chaotic flash of brilliant ideas coming out of nowhere. And Hardy was the one building the lightning rod. His job was to take that raw, intuitive energy and shape it into the rigorous, step-by-step proofs that Western mathematics demanded, to convince the world that Ramanujan's wild guesses were actually profound truths.
And for Ramanujan, this wasn't some poetic idea. He truly believed it. He was a devout Hindu, and he would say that his family's goddess, Namagiri, literally put the equations on his tongue while he was sleeping. You can just imagine how that went over with Hardy, who was a staunch atheist.
He could never understand it, but he couldn't argue with the results. He just had to respect it.
And this brings us to maybe the most famous story about the two of them. Ramanujan is sick, he's in a hospital in London, and Hardy comes to visit. To make some small talk, Hardy says, "You know, the number of my taxi was 1729. Seems like a rather dull number."
And Ramanujan, supposedly without even pausing, just lights up and says, "No, Hardy, it is a very interesting number." He just knew, off the top of his head, that it was the smallest number that could be written as the sum of two cubes in two different ways. Think about that. For him, this wasn't a calculation. It was like he was just introducing Hardy to an old friend. He knew numbers that intimately.
But tragically, this incredible partnership couldn't last. The cold, damp English climate was brutal for someone from South India, and on top of that, he was a strict vegetarian, and trying to get proper food during wartime rationing was nearly impossible. The work was intense, and his health just collapsed. He returned to India a hero, but he was already dying.
32. He was only 32 years old when he died. It's just heartbreaking. But he left behind these notebooks, just crammed with thousands of theorems, most of them with no proof. It was as if he was in a race against time, just trying to get it all down on paper before it was too late. And for the last 100 years, mathematicians have basically been trying to catch up and figure it all out.
And that's the truly wild part. This isn't just a history lesson. His work is still alive. Stuff he jotted down a century ago is now being used in fields he couldn't have even dreamed of. I mean, his Mach theta functions, which were found in a lost notebook decades after his death, are now essential for physicists calculating the entropy of black holes. It's just mind-blowing.
And it all comes back to this. For him, this wasn't about fame or prizes or being clever. An equation was beautiful because for him, it was a piece of the divine. It was a glimpse into the actual mind of God, expressed through the language of numbers.
You know, his story is incredible, but it also leaves you with this kind of haunting question, doesn't it? It makes you wonder, how many other Ramanujans are out there right now? People with these brilliant, world-changing ideas who just don't have a Hardy to send their letter to. What genius are we just completely overlooking today?